Germany has a long history of motoring excellence, and the top rank is BMW, powerful and yet refined. Vehicles designed for people who demand the best and create excitement. BMW strives to maintain its reputation as the maker of exciting machines meant to be driven. The very end motorworks of BMW was found in March 1916, with the merger of Rupp Engine Works and Otto Aircraft Works. Initially, the company produced high-performance aircraft engines that powered German fighters in World War I. When the war ended, the Treaty of Versailles outlawed the production of aircraft engines in Germany. BMW turned to motorcycles. In 1923, BMW unveiled the A32. The design and the engineering worked. The motorbike became the favorite with racers throughout the 1920s. The first automobile produced by BMW was the small 315 Dixie. This low-cost vehicle was built to meet the needs of a country still recovering from an economically devastating war. Eager to bunch out from motorcycles, BMW began constructing actually under the license of the British Austin company. The press called it the best small car in the market. Its strong sales meant BMW has succeeded breaking into the car-making business. The outbreak of war in 1939 meant that BMW would have to suspend the car production. The company focused all its resources on the war effort. After the war, BMW had to rebuild its operations from scratch. In 1952, its factories were up and running, and it was getting ready to launch its first post-war automobile. However, the very conservative and underpowered car was not successful. In the mid-1950s, BMW stunned to the automotive world with a pair of sensational Grand Touring coupes and convertibles. While most Germans couldn't afford these elegant sport cars, they felt finding a comfortable and affordable small car is a problem. BMW had an answer and brought out the Isetta, the unusual vehicle with the door in front and a motorcycle engine. BMW built a large corporate headquarters and powerhouse where it begins to update the entire product line. New models and clearly showed the philosophy that drove the company. BMW was ready to launch its first sport car since the 1950s, the Z3. The sales surpassed all expectations. The Z3 was the first BMW built in North America at the company's new South Carolina plant. The expansion continued at BMW with its X5, the company's first sport utility vehicle. Although the SUV market was crowded, the X5 distinguished itself as a true BMW and became an instant success. The redesigned BMW Mini started Minimania. In an age where many sport car companies were in race to build the biggest SUVs, BMW buckled the trend. Back in 2006, BMW joined forces with a Chinese partner to form BMW Brilliance Automotive Limited. The joint venture would handle production, sales and customer support for BMW vehicles in the People's Republic of China. The plant Dandong in Shenyang opened in May the following year, producing cars exclusively for the local market. In 2014, BMW embarks on a new era of electric mobility. With the BMW i8 and i3, the new brand i presented the first all-electric series production model from the BMW Group. Propelled by an electric motor and thus entirely emission-free, this vehicle delivers a completely new driving experience that is compelling for its agility and sheer fun. Today, BMW's product line comprises 39 models with 269 different engines. A single car consists of 20,000 single components. For all models together, BMW currently produces and stores 290,000 spare part positions.
BMW uses injection molding technology for the production of its parts. Material for the part is fed into a heated barrel, mixed and forced into a mold cavity where it cools and hardens to the configuration of the cavity. After a product is designed, usually by an industrial designer or an engineer, molds are made by a mold maker from metal, usually either steel or aluminum, and precision machined to form the features of the desired part. Frequently, new tools need to be designed and manufactured, because new parts tend to be of new shapes and sizes. Machinery has to be readjusted or perhaps even reconstructed if the differences are radical. Injection molds have limited durability and must be produced on a regular basis. This means that the tools for producing the new injection molds might even have to be readjusted or changed to allow for the new molds. The preparation of new tools affords large investments in terms of time and money. However, the time to market will still remain extended for new products, meaning that BMW will need more time to respond to shifting trends in consumer preferences. Readjustment of equipment between batches is another challenge with this type of manufacturing technique. A car will tend to consist of a very large number of parts, making it impractical to have a dedicated machinery for each part. Instead, manufacturing tools and machines are designed to be able to manufacture many different types of parts. However, machinery requires readjustment and calibration when shifting from production one part to another. Downtime for the machines are the consequences, leading to reduced productivity. BMW produces the vast majority of its parts in Europe. Centralized production of parts with injection molding technology allows for economics of scale to be realized. Centralized production allows BMW to run larger batch sizes. Quality might be another motivational factor. Europe is a development and advanced economy with experienced suppliers. It could conceivably be more challenging to produce similar qualities in another country. Parts are shipped from Europe to their respective markets. Intercontinental shipping times vary with destination, but may take several months. Parts first arrive at centrally placed warehouses. For instance, in terms of spare parts, consumers expect any problem with their cars to be fixable in fast and effective manner. At the same time, it is not practically possible for a garage to keep stocks of all spare parts that might be needed. For BMW's supply chain, this means that a large amount of parts must be stored in central warehouses, but at the same time available for garages within a vast window of time. In conclusion, BMW's current production and distribution strategy applies a proven and reliable technology, guarantees high product quality, and allows for economies of scale. However, there are a lot of problems. Molding injection is a cost-intensive technology. Initial and maintenance costs are high. The relatively high downtimes create further costs. Finally, there is a high time to market, and due to centralized production, high lead times. Finally, a high stock is required. A promising alternative provides additive manufacturing, or better known as 3D printing.
Additive manufacturing and 3D printing are general terms encompassing a variety of systems used to create three-dimensional physical parts and models directly from digital data. These systems primarily manufacture using a layer-by-layer or additive means of construction. Additive technologies are based on the solid modeling portion of computer-aided design, or CAD. Additive systems use the solid modeling data to build in extremely thin cross-sectional layers. This permits manufacture of complex shapes and surfaces much more simply than by conventional methods.
For this reason, parts that could be manufactured by additive techniques would require little to no adjustment. Resulting, fewer production tools would have to be designed and investment costs be reduced. If bottleneck parts in the preparation process could be manufactured with these techniques, time to market would also be reduced. If all parts were made in additive fashion, tool design and manufacture time would be minimized. For general mass production of parts, there are more benefits. In the nature of additive manufacturing, machinery would require little to no readjustment between batches. As a matter of fact, a machine could potentially produce a batch of completely different parts at the same time. This is especially valuable in a production plant where it is necessary to produce a wide range of different parts. With readjustment downtime between batches theoretically eliminated, batch sizes could be reduced, leading to lower storage and less tied-up capital. This flexibility of manufacturing would also allow for low-demand parts to be produced at similar cost levels as other parts. Parts could essentially be produced on demand. With the importance of batch size being reduced, the economies of scale dissipates. This would lower the incentives for the highly centralized production of parts currently employed. Allowing for more decentralization of parts production could lead to benefits in the BMW part supply chain. The first and more obvious change would be reduction in transportation costs. With today's highly efficient shipping options, the actual cost of moving the goods themselves might not be too large. However, large shipment sizes and long transportation times would add a significant tied-up capital to the list of drawbacks. Perhaps more critical, the extensive warehousing this long-distance shipping translates into could be reduced. As explained, the very large number of different spare parts BMW must support means an enormous warehouse problem and associates costs. Decentralized parts production would remove the need to stockpile in order to account for long distances. Decentralized production based on flexible manufacturing techniques would allow for local production of spare parts more or less on demand. This would reduce the amount of storage needed even further. In an extreme case, only a small buffer inventory of each type of part would be required in order to account for variances in demand. In this case, a large part of BMW's downstream spare parts supply chain would be exchanged with an upstream raw materials supply chain. Raw materials like metals would be easier to store than the parts themselves. Firstly, BMW would have to account for less types of materials than parts, reducing total amount of storage needed. Secondly, such materials could potentially be stored as bulk or spools, which is generally easier and less expensive than storage of high-performance car parts. Additive manufacturing provides a great range of advantages in parts production. While General Electric already incorporates additive manufacturing in its production process, BMW currently does research to explore the potential of this innovative manufacturing technique. BMW sees great potential for additive manufacturing in the future. However, currently costs are very high. The main challenge provides the development of the material. BMW is confident to employ additive manufacturing in around 10 years and sees potential to produce a majority of parts within 15 to 20 years.